Guys, I hope you guys are fine. In this video we are going to talk about the implementation of Dijkstra's algorithm, and we are going to use the adjacency list representation of the graph. Now remember, we are going to deal with a directed weighted graph. This is the sample graph. We have done the earlier implementation with the help of an adjacency matrix, but this time around we are going to use the adjacency list representation. So let's get down to coding. I'm going to create a file called Dijkstra1.cpp. In this file, let's begin with hash include iostream. I'm going to include hash include list for the list container that we are going to use. And let's go back to the slide here, to our sample graph. It looks like this. It has 5 vertices. So as per our representation, I'm going to make a pair, a dynamic array of list which contains a pair of integers. So I will be going ahead and storing the destination along with the weight, and I'm going to go ahead and make a dynamic array of 5 vertices because there are 5. As usual, I'm going to create an add edge function. I'm going to pass it the adjacency list representation, the source vertex 0, the destination vertex 1, and the weight on this edge, which is 2. Similarly, I'm going to go ahead and do this for the other edges 0, 2, and 4. Let me tackle the source vertex 1. From 1 to 2, I have an edge carrying a weight of 1. I'm also going to go ahead and explore the edge from vertex 1 to vertex 3, which carries a weight of 4 here, and we are also going to look at vertex 1 to vertex 4 with the edge weight of 5. So we are talking about that one. Let me go ahead and let me proceed with source vertex 2. I have an edge going from 2 to 1 with a weight of 5, and another edge from 2 to 3 with a weight of 2, and another one from vertex 2 to vertex 4 with a weight of 3. There is only one outgoing edge from vertex 3 to 4 which carries a weight of 1. So vertex 3 to vertex 4 with a weight of 1. There are no edges which go out from vertex number 4. So let's code out the add edge function, which is pretty straightforward. Add edge list pair integer star al. U is my source vertex, V is my destination vertex, and W is my edge. What we are going to do next is al u dot pushback make pair, to make a pair of the destination vertex and the edge on that, and let's give a call to our Dijkstra function, to which I pass the adjacency list along with the source vertex, which is 0. So I'm planning to take 0 as the source vertex from which I would start exploring the Dijkstra's algorithm. So in essence, I am trying to find out the distance of all vertices from vertex number 0. So void Dijkstra, I have list pair integer star al, and S stands for source here. I will declare a distance array of 5 vertices. I will have visited 5, so I'll make 2 arrays. Distance array to hold the distance of all vertices, initially set to the maximum integer value. So I can do that like this, and then my visited array is set to 0. That means none of the nodes have been visited so far. Distance of the source from the source is set to 0. I repeat the process 4 times, which is 1 less than the number of vertices. and I simply give a call to find the minimum distance. To this I pass the distance array and I pass the visited array. Let's code out the minimum distance function. So let's hold the values in the distance array, in the boolean visited array, and what we're going to do is I'm going to take a variable min, which is going to hold the minimum distance index, which will hold which vertex has the minimum distance. I'm going to loop through all the vertices here, and while looping through all the vertices, I'm going to check if you find a distance which is less than or equal to minimum, and you have not visited that vertex so far, I should go ahead and I should update the minimum distance as dist_i, and I should go ahead and I should update the index to hold this I. So this returns me the visitor that you have not visited so far, and it has the minimum distance. I would mark this vertex with the minimum distance as visited. Now let's explore all the vertices which are adjacent to this. So I will go ahead and I would be using an iterator. The starting point for that iterator is elu.begin. It explores all of the vertices that are present here to an it++. Now remember, we are interested in a vertex that I have not visited so far. So it first is the destination vertex. If you have not visited the vertex, there obviously is a edge here. So, and the distance of u is not equal to int max, and the distance to this vertex which you have not visited so far happens to be greater than the distance to u plus this distance given by it second. You should go ahead and update this distance because it is more, and we are trying to find out in every iteration we are trying to lower down this distance u plus it second. At this point we should simply print out the distances from our source vertex. I0 I is less than 5, I plus plus. I will do a cout of 0, and the distance is given by dist of I. I'll go ahead and change the line here, and let's go ahead and let's try to compile the program. So g++ Dijkstra 1.cpp, got lucky there, no errors, e dot out. So minimum distance from 0 to 0 is 0, 0 to 2. I think it's better if we display the vertices also here, so this would make for a nice reading. Let's compile and run it again. So 0 to 1 distance is 2, 0 to 2 we can reach in 3 distance, 0 to 3 in 5, and 0 to 4 in 6. Now if you look at this here, I got distance array as 0, 2, 3, 5, 6, which is precisely given here also. So I hope you guys enjoyed this video. This was about implementation of the Dijkstra's algorithm when you are representing a graph as an adjacency list. Goodbye, be safe, thank you.